In this video, we are going to use trigonometric substitution to evaluate an integral. The question is to evaluate the integral of 5 divided by 9 by square root of 9 plus x squared dx. So there are three basic recommended trigonometric substitution. One where the integrand involves square root of a squared minus x squared. The other one, square root of a squared plus x squared, and the last one, square root of x squared minus a squared. In this case, we have square root of 9 minus plus x squared. In this, that means we are using the second case, and the recommended substitution say that replace set x to be a tangent of theta. Our a square is now, so a is 3. We assume that a is positive. So here we are going to use a right triangle. So set this is our theta, and we said x is equal to 3 tangent of theta. It means that tangent theta is x over 3. Now remember, tangent is opposite over adjacent. So the opposite here is x, the adjacent is 3. And therefore, to get the hypotenuse, we just take the square root of, we know that hypotenuse square is adjacent square plus opposite square. So this is just square root of 9 plus x squared. And from this, we can also take dx. Dx is equal to, take the derivative of the right hand side, which is 3 secant squared theta and d theta. So that's what we do the solution we have of this. From here, we can also get all the other remaining 5 trigonometric functions. So, for example, sine of theta is just going to be x over square root of 9 plus x squared. Cosine of theta is going to be 3 over square root of 9 plus x squared. And for tangent is now, which is the reciprocal of tangent, is going to be 3 over x. Our integral, we'll name the integral I. Integral is 5 over, so I, integral of 5 over square root of 9 plus x squared dx. Now see that we can move the 5 out. I'll get integral of 1 over square root of 9 plus x squared, then dx. Now, what is x again? So we do the substitution at this point. So equal 5 integral of 1 over square root of 9 plus x is 3 tangent theta. So you square it, you get 9 tangent square theta, and then the dx, we found it to be 3 secant square theta and d theta. Okay, so simplify, we get 5 integral of 3 secant square theta over, now factor out that, now you get 3 square root of 1 plus tangent square theta and d theta there. And what is 1 plus tangent square? 1 plus tangent square is 1 plus tangent square is secant square. So 1 plus tangent theta is secant square theta. So you take the square, you get secant theta. So therefore, we get 5 integral of 3 secant theta divided by 3 secant square theta on top, 3 secant theta on the bottom, and d theta. So that is, we can simplify 3. Okay, remember, we know that a squared divided by a is a, so secant square divided by secant is just secant theta on top. A. That means we have 5 integral of secant theta and d theta. And by the basic rule of integration, or it is known that this is integral of ln absolute value of secant theta plus tangent theta plus constant. Now, we said that, going back up here, we know that tangent theta is, or using the triangle, we can determine what secant theta is. Secant is 1 over cosine. That means the reciprocal of cosine. That means the hypotenuse divided by the adjacent. Therefore, secant theta is square root of 9 plus 8 squared over 3. And tangent we said was, so plus, what is tangent? Tangent is 3 x over 3. And in absolute value, we have ln 5, okay, plus constant. Okay, so you can go back and double check. Tangent is opposite divided by adjacent, and secant is hypotenuse divided by adjacent. So that means integral of 5 over square root of 9 plus x squared dx is 5 ln of absolute value of x plus square root of 9 plus x squared over 3 then plus constant. And that's conclude our answer.